These are the basic engine parts that make your car's engine run. Each one plays a crucial role in converting fuel into motion, and without them working together, your engine wouldn't function properly. Alright, first up, we have the engine block. This is the foundation of the entire engine. It's usually made of cast iron or aluminum and houses most of the key components. Think of it as the skeleton of the engine. Inside the block, you'll find cylinders, passages for coolant, and oil flow channels. Without the block, you wouldn't have a place to mount all the other parts. Now, let's talk about the cylinders. These are the spaces inside the engine block where the pistons move up and down. The number of cylinders in an engine can vary: 4, 6, 8, or even more. More cylinders usually mean more power, but also more fuel consumption. The cylinders have to be strong and precisely machined to allow smooth movement of the pistons. Speaking of pistons, these are like the heart of the engine's movement. They're metal components that move up and down inside the cylinders. The motion of the pistons is what generates power. When fuel burns, it creates an explosion that forces the piston down, which in turn powers the crankshaft. Now, let's talk about piston rings. These small but crucial components fit around the piston and serve three important purposes. They keep the combustion gases from leaking into the crankcase, they help regulate oil usage, and they reduce friction between the piston and the cylinder wall. Without piston rings, you'd have a lot of oil burning up, which means less efficiency and more engine wear. Next, we have the connecting rod. This part connects the piston to the crankshaft. Every time the piston moves up and down, the connecting rod transfers that motion to the crankshaft, converting straight line movement into rotational motion. This is what eventually drives the wheels of your vehicle. Speaking of the crankshaft, this is one of the most vital parts of the engine. It's a long, rotating shaft that converts the up and down movement of the pistons into a spinning motion that powers the drivetrain. The crankshaft has to be very strong because it handles a lot of force from the pistons firing off constantly. Now, let's move up to the top of the engine. Sitting on top of the engine block is the cylinder head. This component seals the cylinders and contains other important parts, like the combustion chamber, valves, and camshaft. The cylinder head also helps with the flow of air and fuel into the engine while allowing exhaust gases to exit. Inside the cylinder head, we have the combustion chamber. This is where the magic happens. The combustion chamber is the space where fuel and air mix and ignite, creating an explosion that drives the piston down. The design of the combustion chamber affects engine efficiency, power, and emissions. Now, let's talk about valves. There are two types: intake valves and exhaust valves. The intake valve lets the air-fuel mixture enter the combustion chamber, while the exhaust valve allows burnt gases to exit. These valves open and close at precise times to keep the engine running smoothly. To control the opening and closing of the valves, we have the camshaft. The camshaft has small lobes or cams that push against the lifters or followers, which then move the valves. The camshaft can be located in the engine block, in older designs, or in the cylinder head, in overhead cam engines. Its timing is synchronized with the crankshaft using a timing belt or chain. The lifters, sometimes called followers, sit between the camshaft and the valves. They transfer the camshaft's motion to the rocker arms or directly to the valves, depending on the engine design. Some engines use hydraulic lifters, which automatically adjust to keep the valves working properly without constant maintenance. Next, we have the rocker arms. These small levers transfer motion from the camshaft to the valves. As the camshaft rotates, the rocker arms push the valves open and then allow them to close again when the cam lobe moves away. Keeping everything in check are the valve springs. These springs ensure that the valves return to their closed position after being pushed open. They play a crucial role in making sure the engine maintains proper timing and efficiency. And we have the flywheel. This is a heavy rotating disc attached to the crankshaft. The flywheel helps maintain smooth engine operation by storing rotational energy and keeping the crankshaft spinning evenly. It also plays a role in the starting process by helping the starter motor crank the engine. Let me know in the comments what engine-related topic you'd like to learn about next. Thanks for watching, and remember, learn something new every day.